In this example, we need to find the limit of this function given over here at 0, right? As when h gets closer and closer to 0, we need to see where this function approaches, and we need to find that limit if it exists, right? So that's what we need to find. So how can we work on this problem? So let's try to see how the function look like over here. The function is given here as cube of 7 plus h minus 343 at the top, right, and then h at the bottom. So if you just look like here, it looks like the cosine function. So if you want to try to use the quotient rule, let's try to do that. But remember, on the quotient rule, the limit of the denominator function, if that approaches to 0, then we cannot use the quotient rule, and that's exactly happening over here. When h gets closer and closer to 0, the denominator approaches to 0, so we cannot use the quotient rule. So we need to now see some other techniques so that we can actually use evaluate the limit. In this particular example, it's actually not only when h gets closer and closer to 0, it's not only the denominator approaches to 0, but you can see the numerator, which is a polynomial, right? So we can, by using the direct substitution property, this approaches to 0. On that case, we'll have 7 plus 0 and then cube of that, which is what is 7 cube? Oh, that is 343. So if that is the case, it turns out that the numerator or the top function also approaches to 0. So it's not only the denominator, but also the numerator is 0. So on that case, you can say that this is actually the indeterminate form, right? So that's what we call, if you have the 0 at the top and then 0 at the bottom, then we can call this is actually the indeterminate form of the type 0 over 0. So if we have the indeterminate form, what is the idea? What can we do here? If we have the indeterminate form, actually we try to see if we have the 0 common factor, right, at the top and bottom, and then we try to see if we can avoid, like, cancel that out, and then see the another functions, like when we cancel out the 0 common factor, whatever left over, we try to find the limit on that. So on this example, you can see the denominator is h. So we can, if we can find out h as a common factor from the top, and because that's where the denominator is 0, right? So if we can factor out that 0 factor from the top and then cancel out that 0 factor, and then probably we can evaluate the limit. So let's try to see how can we do that. Okay, let me just look into the top function here, or the numerator, where I have 7 plus h cube minus 343. I'm going to actually expand this and then see what type of expression I will get. Okay, so let's try to do that. But if you look into this, the top function here is a cube of 7 plus h minus 343. You can see here I have a cube of 7 plus h. So what does that mean? How can I expand that? Cube of 7 plus h mean, actually, if we multiply 7 plus h, right, times, let's say 7 plus h times 7 plus h, right? So if you multiply these expression together, then we can get the expansion of cube of 7 plus h. So, but how can we multiply this? We can multiply 7 times 7 with 7 times h. We can do that, right? So we can just first multiply these two by using the FOIL. So let's do that. So 7 times 7 times 7 will be 49, right? And then 7 times h will be 7h, right? In the same way, let's multiply the inside terms, which is again 7h, right? And then let's multiply the last term, then we get h times h will be h squared. So this is the expansion we get. We need to multiply that with 7 plus h. Let me a little bit combine this one. I'll get 49. I have 7h here, 7h here. When I combine, I'll get 14h, right, plus h squared times 7 plus h. Can I expand further? Yes, right. I can still distribute by 49. 49 times 7 will be, what is that? What is 49 times 7? 343. Okay, write that down, right? And let me distribute or multiply 49 by h. So that will be plus 49h, right? Let me do the same thing by 14 times h. When I multiply with that to 7, what is 14 times 7? This is 98. Okay, so then 98h, right? And then 14h multiplied with h will be 14h square, right? Okay, so we still need to multiply by h square, so h square times 7 will be 7h square, have that. And then we need to multiply h square with h, which is h cube. So that's what we have. So this is actually, if we combine the like terms, we have 343 here, so write that down. And then 49h plus 98h, combine these two together, what do we get? 49 plus 98 will be, is it 147? Okay, then write it down. Okay, and then in a similar way, combine these two terms, which are like term, right? We can combine, and then we get 14 plus 7 will be 21h square, right, plus h cube. This is the expansion I get for cube of 7 plus h. Okay, so if that is the case, write that down over here. Then we get, what do we get on the numerator? We get 343 plus 147h plus 21h square plus h cube is the expansion of cube of 7 plus h minus 343, right? So this term over here, its expansion is over here, minus 343. All right, so that's what we get over here. That is in the numerator. But when I combine, you can see 343 and then 343, I get 0, right? So I can cancel that out, and then I left over with 147h plus 21h square plus h cube. So that's what I get on the numerator. So if that is the case, remember that our problem is to evaluate the limit of this function given over here. I'm just working with the numerator here. I just try to see how the numerator look like, and then it turns out this is actually 147h plus 21h square plus h cube. Okay, so if that is the case, let me write that down over here. Since our goal is to evaluate the limit of this numerator, which is 147h plus 21h square plus h cube, right? So that's what we have over here, and then everything divided by that will be h. Still, like at the first time when we try to use the quotient rule, we will have the 0 on the denominator, 0 on the numerator, so it's still indeterminate form. But now actually I can see there on the numerator, if I take the h out as a common factor, I'll get 147 plus 21h plus h square, right? And everything under that will be just h. All the works that I have done over here, remember, like I said at the beginning, I need to take out the 0 common factor, right? So cancel out the 0 common factor, and then the denominator was h, and that's why the denominator was 0. I was trying to see if I can get h as a common factor on the numerator. I work all of these work over here, and it turns out that I do have the h as a common factor, which I can now cancel that out, and then I'll just have to then evaluate the limit of 147 plus 21h plus h square. And this is just the polynomial function, right? Polynomial function, like function of h. So I can use the direct substitution property, which is just replace h by 0. So on that case, this will be 147 plus 21 times, what was that? Replace h by 0, plus by using the direct substitution property, I can just write it down in this way, and this is just equal to 147. Or you can say that when h gets closer and closer to 0, this term vanishes, this term gets closer and closer to 0, that term gets closer and closer to 0, so we just left over with 147, because when h gets closer and closer to 0, the constant term will be as it is, right? So that's the limit. And well, yeah, we were able to evaluate the limit of this function.